Welcome back my dear students, a very good morning, good afternoon and good evening to all of you. This is the TKM2 subject lecture on the course under the NPTEL MOOC, and we are in the 29th lecture. That means, we are almost at the fag end of the 6th week. So, we will have the 30th week 30th lecture, it will end the 6th week, and then we will basically have another 10 lectures to wrap up the course. Anyway, if you remember, we were discussing, and as you know, I am Raghunandan Sengupta from the IME department, IIT Kanpur. So, as you know, we were discussing the fractional factors models. So, basically you want to do it combining different factors, basic variables would be there, and then you basically combine them depending on their overall effect or robustness on the model, their final combined effect which is there. And we saw that for different examples, different concepts, how you can basically do the folding. That means, you go one after the other, try to basically encompass as much as information related to the variables are possible, and take the number of variables to be the least, such that you are able to predict the highest. That means, you are trying to use in a very simple layman terms, least amount of resources to get the maximum amount of output. That is what is actually designed. Now, considering the example, so to separate the main effects in the two factor interaction model, the full fold over technique is used. So, you basically go fold it like as you are wrapping up a cloth or wrapping up a bed sheet. So, how you do that? You are trying to basically encompass all the characteristics of the previous set of variables. So, to separate the main effects and the two factor interaction, the full fold over technique is used, and a second fraction is run with all the signs reversed. So, basically you are trying to take the overall effect. So, in one case you have taken the some combinations of plus and minus, and in the extreme case you will basically reverse their signs, such that all the combinations are taken. Plus and minus basically saying that you are taking at the highest level of influence and lowest level of influence. Obviously, if they are more than 2, you will do it accordingly. This fold over design along with the observed responses are shown in figure 8.2, and obviously you will put equal weightages. If you remember that if the folds were basically 2 in number, you will take the average half and then do your studies. If it was you are doing a combinations of 3 different concepts of folds. Concept of fold means the total number which you are getting, you will take 1/3. That means, you are putting equal weightage in the first case half, then you are putting equal weightages in the second case 1/3, then it will go into 1/4, 1/4, 1/4, 1/4 and continue. Notice that when we construct a full fold over the resolution of 3 design, we in effect change the signs on the generators that have an odd numbers effects, and then you do it for the even number. The effects estimated for these fractions which we have seen, the overall values for the resolution of the problem or the concept of the problem which you are taking, depending on the optometrist or the ophthalmologist, for the eye resolution, how far the object is, what is the resolution, what is the size of the object, so on and so forth. So, we get the values of the combined factors which we will mention as A prime till G prime. The values are coming as minus 17.68 to 2.68. So, by combining this second fraction with the original ones, we obtain the estimates of the effect. So, we had already got the first set of effects which we discussed in the last minute of the class, which was the 28th one. In the 29th one, we discussed the other fold depending on sign change, and when we considered that, we take the averages of these values. If you remember, the average values are coming out to be, so considering both plus and minus, the values are, I will just read it. So, for the first row A, it will be 1.48 when it is positive and 19.15 it is negative, till the last value which we consider as G, it is 0.13 for positive and minus 2.55 it is negative. Now, if you consider any one of these, like we are considering the third row. So, in effect we are considering that the combined effect on both on the positive and negative side, considering more positive effect and less positive effect, the values or the factors were like this. Like if we consider C as the factor or the variable, then the so called the opposite side effect, which is coming from the combination of not combining, C would be considered as AE plus BF plus DG. So, this basically you are trying to have a complementary sets such that the effects are not equally divided, but the effects are categorized according to the effects, where say for example, the overall effect from one set of factors, I am not using C, one set of factors decreases, so other one increases, and in the other case when you are basically taking the fold like two complementary sets, the other set will decrease, then the first one will increase. If there are 3, so the combinations will be done accordingly and we proceed. The two largest effects are basically B and D as we see. So, I will just mark it accordingly. So, B, the values are B is 38.05 and D is 29.38. So, these are the values. The largest effects are B and D, where my cursor is now hovering. Further, the third largest effects which we see is basically BD, CE and FG, which comes out to be 19.15. So, this is the third largest value. So, it seems reasonable to attribute this to the B and D effects. So, considering that the ranking means what are the effects based on which we consider the overall values. The experimenter used the two factors distance, which if you remember and go back to the original slide, where the distance, resolution, sharpness, size of the objects were basically considered. So, here the experimenter used the two factors distance B and illumination D in the subsequent experiment with other factors, which are A, C, E, F, and found all the effects accordingly. He or she decided to use subjects as blocks in this new experiment rather than ignore a potential subject effect, because several different subjects had to be used to complete the experiment. So, basically rather than considering them on a single individual level, they were considered in blocks and then found the effect depending on the different type of experimenters available data set was there, because people were coming or different objects were being taken to do the study. So, basically you divide it into B and D and the other set of variables accordingly, and did the so called combined effect and found out their effect in the combined level. So, again coming back to the fold over design, but if you remember we had 7 factors, which was k was 7, and hence it is 2 to the power k minus p, that is 7 minus 4, and the third level design model for the eye focus experiment. If you consider the first, this is the same concept. If you consider the first, second, third, fourth row accordingly, they are the run numbers, then you have the basic designs as A, B, C, and the combined factors which we are considering are D, E, F and G. And then you find out the time, which is given in the last. Time means time to in milliseconds, if you consider. So, for these factors, and then you and then the times are coming out to be 91.3, 136.7 till the second last one is 87.3 and 71.9, and the combined factors were coming out to be, let me read it, it is A, B, C, G for the first one, B, C, D, E for the second one, and so on and so forth for the last one was A, D, E, G. The defining relationship for a fold over design. So, we will just go into that. It is often of interest to know the defining relationship of the combined design factors and what is the overall effect. Each separate fractions will have the words L plus U words used as generators. So, L words would basically words of the look like the sign, and U words would be used for the unlike signs, also so called opposite signs. That means, it may not be plus minus, it can be other signs also, but they are not the signs would be used, or the symbols U and L would be used for those sets where you have high level of similarity and for the sets where there are low level of similarities. The combined design will have L plus U minus 1 words used as a generator, but obviously we know that it is n minus capital N minus 1 based on the experimental design which we have. This will be the L words of like sign and U minus words consisting of independent even products of the words of unlike signs. So, even products are words taken 2 at a time, 4 at a time, and so on and so forth, and we will basically find out the combinations accordingly. Consider for example, 8.7 for the first fraction the generators are, as we have mentioned, I would be ABD and then the next generator would be ACE, others would be BCF and ABCG, and for the second fractions they are, and obviously the negative would be taken when the generators are ABD minus ACE minus is the overall effect which is in the opposite direction. So, you will basically consider the LLU combinations which we are talking about just few seconds back. Then other one would be BCF minus and ABCG. In the second fraction we have switched the signs on the generators with an odd number of letters, also note that L plus U is basically given by 1 plus 3 is equal to that is 4. So, obviously, we will take 4 minus 1 combinations. The combined effect design will be for ABCG as a generator and two words that are independent even products of the words of unlike signs and like signs would be taken. For example, if we take the generators as ABD, ACE, then the combined effect would be BCD as a generator which can basically give you the full set of information. The resolution of the fourth design. So, consider for the two fractional factor models which is 2 to the power k minus p which we have been discussing time and again. So, this fractional factorial design is of resolution 4, which means if the mean effects are clear of two factors interaction and some two factor interactions are allied with each other and we can solve the problem. Thus, if a 3 factor and a higher interactions are suppressed, the main effects may be estimated directly on the model level of 2 to the power k minus p on the suffix and the 4 design 1 to the resolution being on the subscript. So, resolution 4 designs are used extensively as screening experiments based on which we analyze what are the next combinations we will consider. So, any 2 to the power k minus p design must contain at least 2 to the power k 2 into k runs. So, obviously, it will mean that we are taking those combinations in this effect as that we have the minimum set of informations available for us. So, resolutions 4 design that contain exactly 2 k runs are called minimal designs. So, this is the minimum number of such runs we can have in order to get the effects described in the least number of such the combinations. So, obviously, if we go for higher levels of combinations, obviously, we will get better results, but anything less would not be tenable. Resolutions of 4 designs may be obtained from resolution 3 designs by the process of fold over. So, if you remember we are going from the second to the third, third to the fourth, we basically fold over and take the maximum amount of information based on which we proceed. To fold over, we add to the original fraction a second fraction with all the signs reversed. So, if you remember as you are doing the folds, we will basically do the combinations of the plus and minus sign and continue doing that such that we get the maximum set of information. Then the plus sign in the identity column for the generators is we would basically the first fraction that could be switched in the second fraction, and in this way we basically find out the different combinations of the plus and minus which can be done. So, this would result in a design of 2 to the power k plus 1 minus p in the superscript, and in the subscript you will basically have 4 which is the level of design which you are basically considering. Sorry that I have been using the word prefix and suffix, is basically superscript to the power which basically gives you the different design variables which are there and the level of such resolutions and the designed level to which the resolution would be basically mapped is basically the subscripts which you are basically considering. So, let us look at an example in the next slide. So, we have a design obtained by fold over which is given by 2 to the power 4 minus 1 and a design level of 4. And here the variables are A, B, C. So, basically A, B, C are the basic design variables based on which you are trying to proceed. So, here the original one was basically 2 to the power 3 minus 1, because 3 was basically the number of variables which we had, which is k. So, with a resolution of 3 and the generator was ABC. So, the combinations were given with the generator was which gave us the best factor. So, let us consider the first row. So, this was plus. So, indicator of the generator was plus effect, this was A was minus, B 1 minus, C was plus. Similarly, if I go to the last row, so they were all positive, that means they were at the highest level of interaction, their effect on the decision making process. Now, with signs switched, so obviously sign switch would means that each combinations of the signs which we had earlier would now be just be reversed. That means, if they were positive, they would be negative, and vice versa. That means, their overall effects, if it was high, it would be now low, and considering that. So, in this effects, the signs of all the generator indicator I would basically now be minus. So, as you see here, and the combinations of the signs for A, B, C would just be reversed. So, if you had initially minus and minus and plus for C. So, that they are now plus, plus and minus. Similarly, for the last column, last row, if we had plus, 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 so they are basically minus, minus, minus. So, they are basically complementary of each other. So, I will just make a note, and this is what we had. This we had for indicator, this is for the indicator. Then this we had for ABC combined with ABC in the switched over. This we had, which is for the switched over, this is for the original one. So, this is just a simple concept which you are trying to utilize. Now, sequential experimentation with resolution 4 designs. So, the simplest way to fold over resolution 4 design is to switch the signs on a single variable of the original design matrix and do it for all the variables. The single factor fold over allows all the two factor interaction involving factors whose signs are switched to be separated and accomplished and basically accomplishes the overall breaking of the two factors into their so called positive and negative effect. We will consider that accordingly. The experiment was conducted to study the effect of 6 factors on the thickness of photoresist coating applied on a silicon wafer. The design factors are basically ABC is what we consider as spin speed, acceleration, volume of resist applied, spin time, resistance viscosity, and the exhaust rate. It can be observed from the table that the largest mean and the mean effects being basically A, B, C, E. And since these effects are allied with phi factor or higher interaction, it is logical to assume that these are real effects. However, the effect estimate for the combinations of A, B, C, E and allies chain is also large. So, it will basically continue depending on the different combinations which we have. Unless other process knowledge or engineering information is available, we do not know whether this, which is A, B, C, E or both of the interactions can be done accordingly. So, the initial 2 to the, because there were 6 independent factors. So, which was A, B, C, D, E, F, and so hence it will be 2 to the power k minus 2. So, k is 6 and the level of design was 4. So, 2 to the power 6 minus 2 and the subscript was 4, superscript being 2 to the power k minus p, which is 6 minus 2. So, design of the spin coating experiment is given. So, here have the speeds. So, A was the speed. So, different combinations of high effect, low effect are combined together. Similarly, if you go to B, if you go to C, if you go to D, if you go to E, if you go to F. So, which are acceleration, volume, time, volume in cc, time in seconds, the viscosity of resistance. So, the resist viscosity consider like that, and the exhaust rate. And the thickness in millimeters are given starting from, for say for example, for the combination when they are at the lowest level minus, the value is 4524, and where the highest level the value is 4510. So, I am only reading the first value and the last value. So, combinations are given. So, half normal plots of the effects of initial spin coating experiment is given, which means that we are basically trying to find out and fit in a normal distribution and check whether the overall distribution effects, combined effects are normally distributed with a certain mean and a certain variance. The fold over design is constructed by setting up a new model. When initially we had considered 2 to the power 6 minus 2 and the design was of third level, but now we are considering the fourth level. So, the fractional factorial designs is considered of 2 to the power 6 minus 2 and for fourth design, and changing the sign of the factor of a, we basically achieve that. The effects that are estimated for the combined set of runs are, so we are ignoring the interaction involving 3 or more factors. So, basically they would be combined effect would be A and AE, then B and AF. So, we have basically what I am talking about is the two sets at which levels you will consider. One set or one silo or one bucket of effects would be A, B, C, D, E, F, A, B, A, C and A, D. I am reading these values, and in the other set effects we will consider these values. So, these values are AE, AF, BC plus DF. So, you are basically taking the combination BD and CF again the combinations, then BE, BF plus CD, CE, DE and EF. So, we are considering them as combined factors which will give us the overall effect. So, for the block 1 initial run, so silos or the effects which you mentioned was basically one was block 1, one was block 2. So, the block 1 and block 2 this initial runs and the block 2 folded runs are given. So, sorry for the resolution because it is very now I will not use the word cluttered, but a lot of information set is here. So, here the standard orders of the runs was basically given from 1 to 32, which is these values. Then you have the block. So, the blocks would basically the first set would be 1 as mentioned here, and the second one, let me change the color, would be 2. So, if I have the effects, so effects are basically the factors are the same initially. So called if I consider the basic factors or basic variables based on which we are proceeding. So, they are as A, B, C, D, E, F. If you read the topmost row, as I take my cursor, which is again I am repeating A, which is for speed, B is for acceleration, C is for the volume in cc, D is in basically time in seconds, E is the resistance or the viscosity and the rest for the resistance, and F is the exhaust rate, and the thickness are given. So, if you remember the thickness are for given here they are given for one set, which is basically for block. So, say for example, for the block 2 means the second combination which you are taking, 1 means for the first combination we are taking. So, if you consider this is the first block, and if you partition them, so all the different combinations of plus and minus are taken for block 1 and block 2. That means, for block 1 for the initial run, block 2 we are trying to basically fold and consider the combined effect. The generators for the original fractions are E, A, B, C and F, B, C, D, and because we change the signs in the column A to create the folds. So, column A basically was the initial set of variables which we had. The generators for the second group of the 16 runs, because if you remember they were 32 runs. So, it have been equally divided into 16 for block 1 and 16 from block 2, which is for the fold one. So, the generators, let me continue reading it. The generators for the second group of 16 runs are E, A, B, C and F and B, C, D. Since there is only one word of like signs, so basically L and if you remember for like signs and unlike signs, and the combined design has only one generator. So, the generator for the combined is basically F and B, C, D. Furthermore, since ABC is a positive in block 1 and ABC is negative. So, if you check this table, it will give you the signs accordingly for ABC. So, hence ABC puts its alias ADEF as compounded with blocks and basically find their overall effect done in such a way that they complement each other and give us the maximum set of information based on the predictive power, because your main task is to predict as high as possible. So, here we generally use 16 additional runs, but only gained 5 additional degrees of freedom for estimating two factors interaction. This is not a terrible efficient use of experiment resources. So, obviously, you can have better or worse depending on different type of combinations of variables we are taking. In a partial fold over or semi fold, we make only one half of the runs required for a complete fold over, which for the spin coated experiment would be 8 runs. So, depending of half of the runs, if you have basically 16, half of them for block 1 or half of them for block 2 would be half of 16, which is 8. The following steps will produce a partial run over design. So, construct a single fold factor fold over from the original design in the usual way by changing the signs on the factor that is involved in the two fold models. Select only half of the fold over runs by choosing those runs where the chosen factors is either at its highest level or the lowest level. Selecting the level that you believe will generate the most desirable response is usually a good idea, and based on that we can basically formulate the model accordingly. So, the partial folds considering the previous example. So, you have now you initially have considered the full fold, that we are basically trying to encompass the maximum set of information. Now, you are doing half of them. So, the readings are basically again on the first column are from 1 to 24. So, you have basically reduced them. So, the blocks again are in the one remains the same, the first block remains the same. The second one you have reduced them by half, and again the A, B, C, D, E, F, which are speed, acceleration, volume, time and resistance for viscosity and exhaust rates, are basically combined in the plus and minus sign in order to find their effects, and the thickness which is given in millimeters is the actual value based on which we are going to do our experiment. So, the alias relations from the partial folds, initially you have done the full fold, and based on that we had the block 2. The partial folds again we divide into blocks. The blocks are, if you consider this, for the first one starts from A to AD, for the second one basically goes from AE to EF. I am just reading so that you understand where the blocks are. The partial fold over technique is very useful when resolution of 4 designs is used, and usually leads to an efficient use of experimental resources, because money, time, energy is important. So, you have to basically find out the maximum effect in the minimum time and minimum resources. Resolution 4 designs always provide good estimates of the main effects, and usually the number of possible two factor interaction that need to be dealized are at the largest level. A partial fold of resolution 4 design would usually support estimation of as many two factor interaction as possible and in the 4 models. So, one advantage of the partial fold over is that it is not orthogonal, that means we are basically not taking one to one correspondences from them. This causes parameter estimates to be correlated and leads to inflation of the set of the data or the information which you have. So, with this I will close this 29th lecture and continue discussion about this fractional factorial models in more details, and the folds and the semi folds later on in the later class. Have a nice day. Thank you very much.